Hi, I am Mark Apolis. Today I am going to walk you through VP.NET SGX enclave system and how we compute the hash shown into the VP.NET client, how we verify it's the right value, and how you can also verify what this hash really means. First, I will start by connecting to VP.NET. So I will get online right now. And as you can see, I have a verify privacy mark on this 0197DD hash, which is a series of digits and letters that will match exactly the secure enclave that is running right now. So if I click this, you can see we have an enclave details page where you have the hash shown. You know it's a valid enclave. It was released on September 24th. And more importantly, we have a link to the source code of the enclave. So if I click here, I access the GitHub page for this VP.NET SGX repository, where you have all the source code of our SGX backend system and can verify how this handles your privacy. So when you connect to our system with WireGuard, all your WireGuard traffic is encrypted and decrypted inside the secure enclave by this file right here. Then the traffic will go through the address translation. So you have this snap.go here and quite a few other things. I will do another video in the future to explain more on the actual process and workings of this project. But first, I'd like to show you how you can compile this and verify that the hash you get as you compile this project is the same as the one we have on our servers. So some prerequisites, you need Linux, you need Docker. So I'm going to get things ready. Actually for Go, IntelliJ SDK and so on EGO, we will install this via Docker, so there's no need to try to find these. You really need Linux, Docker, and actually if you look at this, you need Git, Docker, and Make. So this is what I'm going to be installing. Let me connect to a Linux machine because I'm on a Mac. Here I am, and I will do start by apt update. And I will be installing Git, Docker, and Make on this machine. So let me get things ready. Wait a little bit. The way we've built this is by using Docker. We're able to allow you on your machine to build environment that will be exactly the same as the one we use on our servers. And this will make sure that the hash you get at the end will match the one we have on our servers. So quite a few things happen in there. I'm going to go through it while the installation happens because it can take a little bit of time. We have here this Docker file, which contains some instructions. So this is based on Ubuntu 24. It will get GCC, wget, a few things. This is happening inside Docker, so this is not going to alter what is installed on your machine. It's only happening inside the Docker image. Then we get the SGX repository from Intel. We install from it libsgx, tcapsql, and libsgx enclave command. And once everything is installed, we download and install HSRT and EGO, which EGO being the compiler we use to compile Go code for SGX. So I'm going to start by cloning the repository. And just in preparation of what's coming after that, I'm going to create a Go directory. Typically, you likely have a Go directory already in your home if you use Go. Actually, if I don't create it, Docker will create it a little bit later, but Docker will not create it with the right rights. So I just create it right now in preparation of what is coming up. Next is I'm just going to modify the make file right now too. Yep. And I'm going to be commenting this line right here because this is for running Go imports. I haven't installed Go import on this machine, so I don't want this to cause an error. And I'm going to directly run, no, I'm not going to run Docker, yes, sorry, because I don't have access to Docker, so I'm going to do magical text Docker to add myself to Docker and log out, log in again. And I should be ready to build this Docker image. So I'm just going to run this right now. It will take a little bit of time from downloading. So as we saw in the file earlier, it's going to download Ubuntu, it's going to update it, it's going to install GCC, wget, UPG, curl, just a few things that we typically need to run EGO. And after it's done that, we'll be able to run the make command and see the result of our build. So just a little bit of background on EGO. EGO was made to run, to compile Go code for SGX enclaves. So this allows us to write portable code that can be typically run on many kind of platforms and run it inside secure enclaves with minimal modifications. We had to modify quite a few things to make it work good. Specifically, SGX enclaves can be fairly slow if they deal directly with UDP communication and this kind of things. So we've built a separate program that will run, it is not published here, but that is run outside of the enclave and does not deal with any kind of decryption work. It just forward packets in and out. So you won't be able to run what we do on our servers with only this binary that is right here, but you will still be able to see, confirm the source code we're running matches what you have here. So as you can see, the Docker file is continuing. We are step 6, so it's installing the dependencies from Intel. Let me see what else I can go through while this is going on. So yes, what this program does is it's going to do the decryption and encryption of your traffic with the WireGuard file. It's going to transform your traffic into internet traffic. So it's a very common process known as network address translation. You probably already have this at home. The difference here is we're doing the translation inside the secure enclave. This ensures that all the process that may know who you are for your connection happens inside this encrypted area. There's quite a few things happening in there. One thing that doesn't happen is that we are not storing any private keys or any kind of log on disk. This means that if we, for example, restart the server will not have the same private key anymore because we are not storing it. The private key only exists inside the secure enclave. So this can be more difficult if you're using just vanilla WireGuard. It means the server can change its address. But this is basically the price of privacy for this specific process. So our client will automatically, after it verifies the server's SGX signature, it will verify that everything is good, and then it will retrieve from the server its private key via the SGX secure connection. So this is the safest way we can go with that. So I think the download will be, the setup of the Docker image should be really soon. So I'm going through the next step. I went too low. The next step will be to just run make. I just lost yes. So as you can see, we cloned the repository, we prepared the Docker image for EGO. So really, all that remains is just to run make. The output will have the enclave value. It's actually called a unique ID inside EGO. So I'm just going to type make, and this will mostly run automatically. So as you can see, it's invoking Docker to build using my current user. It invokes the exact command that is EGO go build, and it's putting a VPNet SGX. And once it's built, it will be signed. And once it's signed, the program will verify and put the unique ID. So here we see it. As you see, the unique ID is 0197DD12 and so on, which matches exactly the value we have here, which is the hash of the enclave running on our server currently. So with this, we have just verified that the source code I have here matches exactly the source code of the program that I am being connected to right now. And if you want, you can perform this check too. If you have any questions, feel free to leave a comment on this video or contact us at support@vp.net. And thank you for watching. Have a good day.